Hey everyone, today we're going to talk about the all the variations of the Friedel Crafts reaction, the alkylation of Friedel Crafts, and we're going to start with the first one, the known reaction, which is just a benzene that reacts with an alkyl halide. Let's say it's CH3Cl. It could be like any RCl. Okay, and it has to be with the catalyst AlCl3 Lewis acid. Eventually, what the Lewis acid, the catalyst, does is that it takes this chloride and we make carbocation. So we make this positive because the chloride leaves with its bond. So after that, the benzene can attach itself to the R plus group, so we get benzene that attached to a methyl group. Okay, so this is usually the reaction of the Friedel Crafts alkylation, that it just reacts with an RCl with a catalyst. But there are many more variations to reactions, and we're gonna try to explain them. So the main thing that you need to know is that whenever you can make a carbocation, which is a good electrophile, the benzene can attack it, and then it can attach itself to the benzene. So another way we can make a carbocation like we did here is the reaction number 2. Okay, which we use an alkene in it. So let's say we have this alkene. We can make a carbocation from this alkene by many ways. The first way, we can react it with an acid. The acid can be, let's say, H3PO4 or H2SO4. And obviously, as you learned in Organic Chemistry 1, that the bond can take a hydrogen from the acid, and you get the carbocation here, according to the Markovnikov's rule. Okay, and then the benzene can attach itself here to where the carbocation is. And obviously when you get to this step, you always have to check for rearrangements of the carbocation, and here we don't have any because it's secondary, and here we have primary, here you have secondary, just like it. So if this reacts with benzene, you would get this. Okay, so this is the second variation of the alkylation of Friedel Crafts. Number 3, that you can make a carbocation from an alkene if you react it with let's clear this up. So if you react the alkene with HF and BF3, you will get the same thing. The carbocation here. And then the benzene obviously can attach itself here just like before. Okay, now the fourth reaction that it can happen to form a carbocation that the benzene can attack is when you react an alkene with an acid and AlCl3. You also get the same thing. You get a carbocation here. If you want the mechanism for this reaction, I put it in the description, and you can just click on the link, and there's a link that has pictures of the whole mechanism of this reaction. This reaction can also happen without the HCl. It's actually an equilibrium. Okay, so remember, after you get the carbocation, the same thing happens as before. Your benzene group, your benzene attacks the carbocation and like forms a bond here where the carbocation is. And always remember to check for rearrangements. Variation number 6. Okay, so if you had an alcohol and you react it with BF3, you eliminate the alcohol and you get a carbocation where it was. Why is that? Because the alcohol can attack the BF3 and forms a bond with it, and after it forms a bond with the BF3, it becomes positive. It becomes a good leaving group, and it can leave, and we form a carbocation that the benzene can attack itself, can attach to. And the same thing happened just as before. Okay, and the last variation, it's actually the Friedel Crafts acylation, because we form an acyl group and not an alkyl group. So when you react your benzene with acid anhydride, let's say we had CH3 so this is an acid anhydride. Obviously it could be acyl chloride like this. So these are our two final reactions, and they are more related to the Friedel Crafts acylation. So what happens to know the final product? We're not going to talk about the full mechanism in this video, just like the final product. What happens? So to know your final product with the acid anhydride, always attach your benzene to the carbonyl carbon and the OCOR leaves. So you get this. And obviously this leaving group, if there are water in the environment, it becomes carboxylic acid. And if the benzene reacted with an acyl chloride, which is like the standard reaction, the the standard Friedel Crafts acylation reaction. It also attacks the carbonyl carbon, but this leaves. Then you get the same product actually. Obviously, the second reaction, this one happens faster because the chloride is a weaker base and it leaves better. So you get the same thing. Obviously, if there are water in the environment, you get HCl. Okay, so these are the variations of the Friedel Crafts reactions, the alkylation and the acylation. So I hope this video helped you. If you have any questions, you can message me on Skype, and it's in the description. I offer free help in organic chemistry 1 and 2. Good luck.